And even worse, if you are in deep space, you don't have the protection of the Mars atmosphere, you don't have the protection of the planet itself, so you have 700 millisievert per year. So 700 millisievert per year in deep space as compared to 1 millisievert per year on Earth.
To put things in perspective, 1 year of Earth exposure to cosmic rays is equivalent with 1 day of space radiation exposure in deep space.
Kramer is very familiar with the dangers of space like radiation. Ken can tell us more about SpaceX preparing for this mission, boldly going higher in Dragon than ever before, Ken. What sorts of things do they have to look out for?
Well, the radiation could be extreme. As I said at the briefing, they could get about 3 months worth of radiation you would have on the ISS during the about 3 orbits they're going to do. We're talking about like 7 hours or so.
Every single credible university on the face of the planet acknowledges that radiation exposure on the International Space Station is about 1 sievert to 2 sieverts a year. That shows that, as he just stated, that Polaris Dawn will be receiving 3 months worth in a matter of 7 hours or 5 orbits. That means that they're going to be getting a 1/4 sievert of radiation exposure in a matter of hours. When GSI stated that it was a year to get 1.7 sieverts of radiation exposure, that was before Orion launched in 2014. After Orion launched in 2014, and then again in 2023, now NASA is stating very clearly you get a year's worth of radiation in 1 day when in deep space. And that brings it to 1.7 sieverts a day that Apollo would have been exposed to for 14 days. And that's not what the REM count shows, which either NASA is lying here by saying all of this, or NASA was lying in the 60s when they said they went beyond low Earth orbit. So when you see cherry picking from these conspiracy theorists who are trying to say that radiation isn't real and isn't fatal, even though the only reason we aren't going out there is radiation, and all NASA's doing is sending radiation probes and studying radiation fields, they're just fucking cherry picking and ignorant of exactly what the magnetosphere is, where the Van Allen belts get their radiation, how the bow shock of the magnetosphere works, how electromagnetic reconnection works because of the magnetosheath, and how the polar cusps get fed all the radiation their precious Van Allen belts have.
As far as we can go is 230 miles. The end of the atmosphere is 6,213 miles out. That is just the end of the blue right there. Now, if you were to shoot through this, as they say, we could go out really fast this way, that's impossible. That's shooting a bullet into a sea of lava, a paper bullet into a sea of lava with what we have. And then not only is it going into the heaviest, absolutely the thickest layers to leave, or if it goes out this way, it's going into a shotgun of all of the exiling, released particles from all of the magnetosphere's tail. So there's no way out through speed. Plus, when we get out here, we have found that this is 100% of what is surrounding the Earth's active shielding. 1% makes it into right here. And this is what interacts with the magnetic reconnective points in itself, causing this plasma state, and then through the magnetopause and through the polar cusps, a few make it down, most of it leave through the tail, but through the neutral point it finds its way back through. All of these find its way into, just at the north and south points, they find that 1% makes 1% into us, and that 1% of that 1% is filtered all the way down. And there is where the last of it finally is filtered out through the ionosphere, and it stops, and we get those beautiful aurora borealis lights, and everyone oohs and ahs at the greens and purples and the beauty of it all.